Get to know PSYONIC, the company redefining what it means to be human through bionic technologies. Hey guys, and welcome to one more episode of Builder Nation. For today's interview, we have Aadeel Akhtar, founder and CEO of this company. So welcome. Thank you so much for being here. Such a pleasure to have you.
Yeah, thank you for having me. I'm really excited.
Me too. I think it's going to be great. We were talking, guys, before the actual interview. And wow, I discovered so much in like 5 minutes. So thank you so much for being here.
So this is actually, as you mentioned, something I started thinking about and something I wanted to do since I was 7 years old was to build bionic limbs. And I was visiting Pakistan. So my parents are originally from Pakistan. I was born in the Chicago suburbs, but I was visiting there when I was 7. And that's the first time I met someone missing a limb. And she was my age, missing her right leg, using a tree branch as a crutch. And that's what inspired me to go into the field. So I got a bachelor's in biology from Loyola University of Chicago, a master's in computer science there as well, taught in their computer science department for a couple of years. And then I went to the University of Illinois in Urbana-Champaign, got another master's in electrical and computer engineering, a PhD in neuroscience. And then I left medical school to run PSYONIC full time because this was a bit more fun.
Wow. This is a really interesting background, I have to say. And so it all started when you were 7, and then you went to school, and then you graduated and everything. But why did you want to create a company?
So, the original plan was actually not to build a company. And the original plan was that I was going to finish medical school. I'd work at an academic hospital, and then we'd do research at the university to build devices like this, but it would stay just like that. Like we'd write papers and we'd do research on these devices. And so while I was doing my PhD, I got the chance to go down to Ecuador, and I was working with a patient there, Juan Suquillo, and he had lost his left hand 35 years prior due to machine gun fire from a helicopter. And he was in the Ecuadorian army, and there was a border war between Ecuador and Peru. And so with our hand, at the time, it was 3 times bigger than an average adult human hand. It had wires going everywhere, plugged into circuit boards, plugged into the wall, plugged into computers, everything, right? But Juan said that he felt as though a part of him had come back. And that was because he made a pinch with his left hand for the first time in 35 years. And he had actually forgotten how to make a pinch with his left hand. And we had to retrain his brain by placing a mirror in front of his amputated side, reflecting his right hand that he still had, tricking his brain into thinking that his left hand was there. And it reactivated his muscles. So when he said that he felt as though a part of him had come back, that's when I realized that if I stay at a university system, then this just ends up as a paper and that's the end of it. If we want everyone to feel the exact same way that Juan did, we needed to commercialize the technology. And so that's when PSYONIC was born. That's how we started turning this into a company instead of just being a university project.
Shocked about this story. Okay, I have a lot of questions to ask. So why don't we start by, I know that you like traveling a lot. You just came back from Australia. Correct me if I'm wrong. What did you do there? I know that it has something to do with bone integration and a surgery. So if you can share a little bit about it, that would be great.
Yeah, absolutely. Just to give you a little bit of context, right? So I've got the hand right over here, right? You can see that I'm moving all the fingers. I'm using these buttons to control it. This is the hand itself. I just popped it off of this little control stick. And if I lost my hand below my elbow, like right around my forearm, you'd go to a clinician. They're called prosthetists, right? They will mold a socket to your residual limb. So it's kind of like if you break your arm and you get a cast made of your arm, it's like that same process. So if I was missing my arm here, I'd get like a cast made, and then I would put my arm into that socket, and there would be muscle sensors embedded in that I could use to control the hand. Now, the thing is that when you're wearing a socket like that, think of it like wearing a shoe over your arm. So it's going to get sweaty. Things are going to shift around. Like it's going to get uncomfortable over time, right? And that's not how your hand is attached to your own body. Your hand is attached to your bones in particular. And so when we went to Australia with an orthopedic surgeon from the Navy, Dr. James Flynn, another orthopedic surgeon from the University of California, San Diego, Dr. Frank Chirapa, and one of the local clinicians, the prosthetist, Alex Hetherington. And we were learning a technique that you can use that takes a titanium implant that will go inside your bone and then comes out of your body. And then the hand itself will connect directly to your bones like a natural hand should. And this just has the potential to have incredible outcomes for patients where they have like full range of motion, and they're not like have issues with like sweating and all these other things that come with wearing this kind of like socket that goes over your residual limb. And so we're able to do that surgery now in San Diego. And so my goal is to turn San Diego into the bionics capital of the world. So Lisa, if you're ever coming to visit us in San Diego, our lab is like a robotics paradise. We can build like any robot you can imagine. So it's a lot of fun.
Well, it does sound like a dream. I didn't know that San Diego was really big in tech. Why did you establish there?
Yeah. So in particular, it's pretty big in biotech and med tech. Not necessarily like the traditional, like deep and hard tech, but it's starting to grow in that respect. Bioengineering is very big there. And a couple other reasons for us to go down there was that we're working closely with the military hospital. And so a lot of our patients are veterans, and a lot of them are getting these advanced surgeries that weren't possible before. Also, UCSD is one of the best engineering schools in the United States. I'm faculty there in their bioengineering department as well. And so we're working with a lot of their faculty now and their surgeons to do some of this cutting edge stuff. The Challenge Athletes Foundation, they hold the Paratriathlon every year. They're located 10 minutes away from us. And then there's a bunch of good clinics. The weather is phenomenal. That was a pretty good reason. There's 2 prosthetic schools that are near us, and there's only about 11 in the entire nation. And then there's a lot of robotics and entertainment companies that are in LA as well that we plan to partner with, hopefully Disney and some of the other ones, and video game companies that are over there as well. So all of these kind of came together, and there wasn't really a big presence of prosthetics there. And so we were like, if we go to San Diego, we have all the pieces to do something revolutionary. So let's bring that all together and then really turn it into the bionics capital of the world.
Wow. I have to ask you about your path being the founder and CEO. And what would you say has been the biggest technical and business challenge as well?
With any startup, it's always like a roller coaster. So you're going to have really high highs and then very like low lows. On the technical side, there's always a new challenge. For example, some of our biggest challenges right now have to do with how do we integrate our hand directly to your bones and directly to your nerves? And how can we do it in a seamless way that people can do any activity of daily living? So like just pushing the grocery cart or going swimming eventually and everything in between. So those are some of the technical challenges that we're facing now. 8 years ago, the technical challenge was like, big one for us was that we started by 3D printing these hands, and we were able to make them extremely low cost from 3D printing. But when we started talking to actual patients, the number one thing they complained about wasn't that their hands were too expensive. The number one issue was that their really expensive hands were breaking all the time. And it's not because they did anything crazy. They would accidentally like hit the hand against the side of a table and it would just break. And that's because they were using rigid materials, but our own fingers, they're flexible, right? If I hit my own hand, it flexes out of the way and it comes back. And so we had the challenge of how could we make our hand super robust to these impacts, still leverage the low-cost manufacturing of 3D printing. And so one example that we did was instead of 3D printing the fingers directly, we would 3D print a mold and then use like silicone and rubber that's kind of more like your own fingers. And then the hands would feel more like your own fingers would. And so if you see, I'm squeezing these fingers together and it's bending kind of like my natural hand would. And I can take this, smash this, and it totally survives the impact and everything still works just fine. That was like one of the huge technical hurdles that we needed to surpass to really get this out to patients in a way that was reliable for them to use on a daily basis without the hands breaking all the time. So you're also asking on the business end. I mean, funding, these things go in cycles, right? And so I remember one of the biggest challenges was, it was end of 2017. We had just come back from China and we tried to do an online fundraiser type thing and it didn't work out very well. And by the end of the year, we had $200 left in our bank account. We were like, oh, now what are we going to do? And earlier that summer, we had applied for a grant from the National Science Foundation in the US. And we found out in December that we got that grant, and that was for $225,000, where you get $200,000 up front. And that was more money than we had ever seen before. And so we go from like $200 left into our bank account, and the next week we have $200,200. We're actually in the middle of an investor round right now as well. And so we're raising between 3 to 5 million total, and anyone can invest. We've opened it to the public. And what's really cool about that is that even our patients have been investing in the company. And so it's like we're building our hands for them, and then they get to be a part of that whole process. And I love it. That is something that I never imagined that we would be able to really do.
That must be really rewarding for you. Thank you so much for sharing and for being super honest about it. I think that's what people value the most. You mentioned the challenges, right? But you guys survived the pandemic and you guys are building hardware and I think also software. So what would you say was the biggest challenge there, talking about the procurement or supply chain issues?
Oh man, that was a pretty big issue for us too, actually. The hand itself, we've 7 different microcontrollers, so 7 different processors that are here, one for each of the motors. So there's 6 motors in the hand. And then there's another one that does the Bluetooth communication and kind of coordinates everything. But 6 of those chips, they just stopped making. We couldn't find them anywhere anymore in the entire world. We basically had to redesign the entire electronics board from scratch using an entirely new chip that was available for us to get. And the thing is, the processor that we got was actually lower cost than the one that we were using before, but it was also not as powerful in terms of computing processing as the one that we had before. And so we had to rewrite the code in such a way that it could run on these processors that weren't as computationally strong. And the silver lining is that our algorithms got way more efficient. And so we could actually run our code way faster than we ever could before. And it made the torque control on our hand even better. So it was like this kind of like benefit that we got that we weren't necessarily expecting that was forced on us because we had this chip shortage. So it's kind of cool how things work out like that and when you least expect it.
Your engineering team and your operations team must be super organized.
My director of engineering, he's been with me even before the company had started. He was one of my undergraduate students when I was a PhD student, and he's been with me the entire time. And he is just a genius when it comes to this kind of stuff. Jesse Cornman, he's our director of engineering. He's done all the electronic designs for every iteration of the hand. And if you ever come by our place, we've got display cases that have all our old versions of the hand, starting from the very first one we built about 8 years ago, and then every iteration that we've made. And it's just really incredible to see the growth of our engineers as well as the improvements on the hands that we've been making over the years.
Whenever I ask hardware companies, how do they organize their actual procurement and supply chain, most of them organize through Google spreadsheets, or they have an actual system.
Well, as you scale, you can only rely on spreadsheets so much, right? And our biggest issue right now is that we've got more demand than we can produce. So our goals are, how can we start building more of these, and how can we get more of these out there? Because there are patients who need them, and also robotics companies are buying a lot of them too. NASA and Meta and Aptronic, they've all purchased our hands, and they're putting them on humanoid robots too. And so it's like this giant increase in demand. So we want to make sure that we're able to keep up with it.
Do you feel pressure? Do you feel happy? Do you feel overwhelmed at some point? Like, how do you feel at this point of your life?
It's always a combination of all of those things, but mostly I'm always grateful. I always feel grateful that I've even had this opportunity because, like I said, this is something I've wanted to do my entire life. And to have that opportunity, I mean, not many people get that opportunity, and it took a lot of hard work to get there, and it's always going to be hard, but because I get to do what I love, it makes it all worth it.
Thank you for sharing. I'm loving this interview. And one of the last questions, what will you say are the next steps for PSYONIC?
So scaling is one of the big ones so that we can start getting our hands on more robots and humans out there. But really, where I'm really excited to go with this stuff is kind of that neural control and bone integration. And actually, we're going to try and do something fun here, just to give you an idea of what that's going to be like. So if everything works properly, you're going to actually get a chance to control this hand yourself from where you're sitting in Mexico right now. Let's see if we can get this to go. Okay, so what I want you to do is I want you to put your hand in front of your camera.
Like this?
Yep. And then let's see if I can get this right. Okay, so go ahead and make a fist.
And make,
Yep, so it's actually copying your movements right now. So you can move individual fingers, like...
Thank you so much. Wow, this is going viral. I mean, this is going viral. It is so cool. I'm shocked. Not only for me, but also for the future patients. I mean, this is going to be great.
Yeah, and so our goal with patients is that they'll be able to do that individual finger control just by using their nerves. And then on the robotic side, the idea is, like, for example, with NASA, that you could be sitting here on Earth controlling something from your camera, but the hand is doing something like up in space. And that's the entire goal of all this stuff. So we're really excited about where we're going to be bringing this stuff in the future.
This is revolutionary. Thank you so much, Aadeel, for sharing this. Thank you so much for taking the time. I highly appreciate it. Last but not least, do you have any social media handles? Where do people find you or the company?
Yeah, so they can find us at psionic.io. And if they're interested in investing, they can go to psionic.io/invest. And then all of our social media handles are at Psionic Inc.
Thank you so much for sharing. And remember, guys, that you can also find more information, interesting articles, interesting interviews like this one directly on our website, ControlHub.com/wheeler-nation. We would love to hear from you. And once again, Aadeel, it was great to have you on board. This was one of the most fun and interesting interviews we have ever held at the Wheeler Nation podcast. So thank you so much for being here today.
Thank you for having me. It's my pleasure.